What is a port? A port is a virtual point where network connections start and end. Ports are software-based and managed by a computer's operating system. Each port is associated with a specific process or service. Ports allow computers to easily differentiate between different kinds of traffic. Emails go to a different port than web pages, for instance, even though both reach a computer over the same internet connection. What is a port number? Ports are standardized across all network-connected devices, with each port assigned a number. Most ports are reserved for certain protocols. For example, all Hypertext Transfer Protocol (HTTP) messages go to port 80. While IP addresses enable messages to go to and from specific devices, port numbers allow targeting of specific services or applications within those devices. How do ports make network connections more efficient? Vastly different types of data flow to and from a computer over the same network connection. The use of ports helps computers understand what to do with the data they receive. Suppose Bob transfers an MP3 audio recording to Alice using the File Transfer Protocol (FTP). If Alice's computer passed the MP3 file data to Alice's email application, the email application would not know how to interpret it. But because Bob's file transfer uses the port designated for transfer, which is the FTP port 21, Alice's computer is able to receive and store the file. Meanwhile, Alice's computer can simultaneously load HTTP web pages using port 80, even though both the web page files and the MP3 sound file flow to Alice's computer over the same Wi-Fi connection. Are ports part of the network layer? The OSI model is a conceptual model of how the Internet works. It divides different Internet services and processes into 7 layers. These layers are OSI model 7 layers. Ports belong to the transport layer, which is layer 4. Only a transport protocol such as the Transmission Control Protocol (TCP) or User Datagram Protocol (UDP) can indicate which port a packet should go to. TCP and UDP headers have a section for indicating port numbers. Network layer protocols, for instance, the Internet Protocol IP, are unaware of what port is in use in a given network connection. In a standard IP header, there is no place to indicate which port the data packet should go to. IP headers only indicate the destination IP address, not the port number at that IP address. Usually, the inability to indicate the port at the network layer has no impact on networking processes, since network layer protocols are almost always used in conjunction with a transport layer protocol. However, this does impact the functionality of testing software, which is software that pings IP addresses using Internet Control Message Protocol (ICMP) packets. ICMP is a network layer protocol that can ping network devices, but without the ability to ping specific ports, network administrators cannot test specific services within those devices. Some ping software, such as MyTraceroute, offers the option to send UDP packets. UDP is a transport layer protocol that can specify a particular port, as opposed to ICMP, which cannot specify a port. By adding a UDP header to ICMP packets, network administrators can test specific ports within a network device. Why do firewalls sometimes block specific ports? A firewall is a network security system that blocks or allows network traffic based on a set of security rules. Firewalls usually sit between a trusted network and an untrusted network. Often the untrusted network is the Internet. For example, office networks often use a firewall to protect their network from online threats. Some attackers try to send malicious traffic to random ports in the hopes that those ports have been left open, meaning they are able to receive traffic. This action is somewhat like a car thief walking down the street and trying the doors of parked vehicles, hoping one of them is unlocked. For this reason, firewalls should be configured to block network traffic directed at most of the available ports. There is no legitimate reason for the vast majority of the available ports to receive traffic. Properly configured firewalls block traffic to all ports by default except for a few predetermined ports known to be in common use. For instance, a corporate firewall could only leave open ports 25, email, 80, web traffic, 443, web traffic, and a few others, allowing internal employees to use these essential services, then block the rest of the 65,000 plus ports. As a more specific example, attackers sometimes attempt to exploit vulnerabilities in the RDP protocol by sending attack traffic to port 3389. To stop these attacks, a firewall may block port 3389 by default. Since this port is only used for remote desktop connections, such a rule has little impact on day-to-day business operations unless employees need to work remotely. We have come to the end of this course. I hope to see you on the next course. Bye for now.